Okay, hello guys. Today our lesson is about forces, pressure, and energy, our third lesson in IGCSE physics. Okay, so here look at our content. We have forces and turning effects, pressure, work, power, and energy, and then last we will learn about energy conservation and efficiency. Okay, so let's go to the first slide, and here you can find this is about moment of force. So maybe you heard of moment, this word very often, right? Maybe you said one moment in a very short period or a very short moment, right? So moment just means a very short time. But in physics, we use moment to represent for a turning effect. So you can see here, people are applying force on the handle, right? Here trying to maybe make it rotate. So if you're using more forces, maybe the handle can rotate at a faster speed, right? And also it's like a seesaw, where you sit at the end of the seesaw, it's easier for you to make it rotate, right? So also for your hand, if the handle has a longer length, maybe it's easier for you to make it rotate, right? And in the second picture, you can find here the moment about, oh, you can find here, you apply the force and you can make it rotate, right? So you can just make a conclusion that when you apply more forces on a rod or on a handle, you can say that it's easier for it to rotate. And also when you increase the length of the handle, also the moment will increase. So you can use them times together and makes a new definition about turning effect that is called moment. Moment. So you can say that moment equals to force times the distance. Okay, but remember that the distance is perpendicular distance, okay? That is because if you're using like this way to rotate the rod, and also another way to rotate the rod, they have a different effect. So we have to determine this, okay? So what is about the perpendicular distance? That is from the central point, we have to draw a perpendicular line to the force, okay, like this way. This means the real distance from the central to the force, okay? So here is a perpendicular distance, right? So if you're using a force like here, that is just perpendicular to the rod, I think is easiest for you to make it rotate, right? So here is a moment of a force. So here you can find if you apply the force for about 3 Newton, and here the distance is 2 meter, and you times them together, and it's 6 Newton meter. Okay. So here you can find there's also two directions for the rotation. You can find here the force just makes the rod like to rotate this direction. We can call it is a anticlockwise direction, right? And you can find in the left figure, the hand wants to make the handle to just rotate this direction. This is a clockwise direction, right? So we can say that moment has two directions. One is clockwise, another is anticlockwise. Okay, so here's the difference. Okay, so you can see here, there's a principle of the moments. You can find, we can make them like a superposition of the moment. So maybe you ask that, what is a superposition? So superposition means addition. You can add different physical properties together. So you can find here, if you just using a 10 Newton object to put it on the maybe a rod, and here the distance from the object to the center is 2 meter. Okay, so another object here is 5 Newton, and its distance to the center is 4 meter, right here. Okay, so here is the force and distance. Okay, so then you can use the definition of moment, right? The force times perpendicular distance. You can set here that this object on the left can afford about a 10 Newton times 2 meters, 20 Newton meters moment, right? And the direction is anti-clockwise. And for here, you can find here the object is 5 Newton, and the distance from the support to the object is 4 meter. So times them together, that is also 20 Newton meter, but the direction is anti-clockwise, right? Clockwise, right? So you can find here the 20 Newton meter anti-clockwise moment equals to any Newton meter clockwise moment. So they can equals to each other. Okay, so here is a principle of the moments. And also in figure B, you can find here, when you're applying a also 10 Newton force to the support distance is 2 meter. And another object find here, the force is 8 Newton and the distance to the support is 1 meter, right? And we can say that it afford a 8 Newton times 1 meter, 8 Newton meters. Maybe it's a clockwise moment, right? And for this 3 Newton object, we can say 3 Newton times 4 meter just rotate us this way, right? Gives a force, makes the rod rotate us this way. So it is 12 Newton meter and also a clockwise moment. So you can find here on the left, the total moment is 20 Newton meter, and on the right is 12 Newton meter plus 8 Newton meter. It is also 20 Newton meter. So we can say we can divide this object into two parts. Okay, so like you're taking a seesaw, and if you want to win the game, maybe you have to find other people to help you, right? Because your moment can make a superposition. This is the basic principle for moment. Okay, so here I hope you can understand this and try to make a clear understanding. Okay. So after this, I would like to tell you a very brand new definition about equilibrium. So for equilibrium, we have already talked about in the forces part, right? We said that equilibrium means that the resultant force equals to zero. But in today's lesson, you have to learn that equilibrium not only represents for the forces that have to be equal to each other or the resultant force is zero, but also today in the moment, the total moment also needs to equal to zero. So why total moment equals to zero? Because if an object has a rotate, we cannot think that is an equilibrium state. Okay, so here please remind that total moment has to equal to zero. Okay, so here are two conditions. The first condition is resultant force equals to zero. I use Fr to represent for resultant force. So capital R means the resultant, and here's the force. Okay, so just try this exercise, please, and try to figure out which force is bigger and which force is smaller than F1, okay? Okay, I think maybe you have an answer, okay? If you doesn't finish the problem, you can just pause the video and try to finish it, okay? And here you can find in this figure, we have two forces, right? On the left, there is maybe a log and its weight is W, right? And on the right, we have a force, maybe it's applied by a human, right? It is F1. And in the first figure, it starts to maybe leave the heavy log, right? So we can say that when this time, the moment just equals to zero, right? Or total moment equals to zero, or it stays in an equilibrium state, right? So if you're using like this from the way to the pivot, the distance is L1. From the pivot to the F1, the perpendicular distance is F2, L2. So we can write down a formula, right? That is y times L1 means here the anticlockwise moment equals to here F1 times F1 times L2 means the clockwise moment, right? So here is y times L1 equals to F1 times L2, okay? So here equals to each other. And for P, you can find here, if you make them, make it to using the formula, like here, y times L, the L1 doesn't change, right? But here you can find the L, like L2, increases, right? It increases the levelness, right? So here, on the left, it equals to the left, right? But on the right, L2 is bigger than L2 in the initial place, right? So here, maybe you don't need to make F2 bigger, you just need to smaller, and it can also equal to each other, right? So we can say that F2, maybe here is smaller than F1 at the top, right? And also for Q, you can find here you change the direction for the force. But here you can find the distance is from the pivot to F2. It's a perpendicular distance, right? So here the distance also bigger than in F1, right? Because here is a diagonal side for the triangle. And here is L2 in the first top figure, right? And here is a L2, new L2, right? So here, using the formula, y times L1 equals to force 2 times L2. The L2 also increases. So here, F2 decreases, okay? So here, the difference. So F2 is smaller than F1. And in R, you can find here, there's a log and F2 applied on the moment. You can find here the y times L1, but here L1 increases, right? Because the pivot distance to the log is increasing. And also you can find here the lever from the pivot to F1, F2, like here F2 times L2. This decreases, right? Because the lever has the same length. If you increase the length of L1, another part L2 will decrease. Okay, so here one is bigger, another is smaller. So here, if you still want to make it in equilibrium, you have to increase the F2, right? So this formula can equals to each other. So here you can say F2 maybe is bigger than in F1, right? So only in P and Q we can say that F2 is bigger, and in R F2 is F2 is smaller in P and Q, right? And in F2 in R F2 is smaller. So we can only choose P and Q. Okay, so here we choose P and Q only. Okay, so here is for today's lesson. I hope you can understand all of this and try to imagine what is the definition of moment and take notes of this. Okay, see you next time. Bye.